Hey guys, in this video I'm going to show you how to print and assemble my Kabrio fingertip mod for the VXC Mat R. I'm making this video because I have seen a lot of people struggle with the assembly, so I want to help you a bit. Let's start with the print settings. Now I'm using a Bambulab P1P with Orca slicer. I provide the 3MF project file with the optimal settings and the printables post, so use it if you can. But if you cannot, it's fine. I will show you what are the important settings you have to change, and hopefully you can find them in your slicer. Let's start with the filament. I suggest using some PLA or PLA+. Now if you want to save a little bit of weight, you can use ASA, but it's going to save you only about half a gram, and it might be much weaker. So let's go to the print settings. I suggest going with 0.12mm layer height. This will make the print look better, the top surface quality of the buttons will be nicer, and it will be also a little bit stronger. I changed the outer wall to 0.5mm just to make it a little bit stronger. Now let's scroll down. We are going to go with Arachne wall generator. It's just better most of the times. Let's now go to the strength settings. I designed this model to be printed with 1 wall loops, which basically means that the whole print is hollow in most of the places. You can even see these pedal sticks, I don't know, are hollow as well. I reduced the top shell layers to 4. I adjusted the top surface pattern and bottom surface pattern to be concentric. It just makes it print easier, a bit faster, and it looks a bit better. Now comes the interesting part, the infill. I basically want to print this with no infill, or no sparse infill. As you can see, I achieved that. We have 0 grams of sparse infill. But the problem is, if you do 0% sparse infill, it actually eliminates even the solid infill, which I don't want, because the solid infill helps us print these top surfaces of the pedals. Now I achieve that by going 1% sparse infill density, and the pattern is lightning. It's important to choose lightning because it's the only one infill pattern that I found that doesn't generate. Another thing that I changed is the internal solid infill pattern to concentric. Again, this just helps us print the top surfaces a bit nicer. Another weight reduction is reduce the sparse infill threshold to 2mm and ensure vertical shell thickness to none. If you don't do it, it will fill most of the mouse with internal solid infill, as you can see all over the purple. You want to reduce this to 2 and none. Let's quickly jump to speed. Nothing much going on here. I just reduced the outer wall speed and acceleration to make it print a little bit nicer. Now let's go to the probably most important setting for this model, and that is support. We need, unfortunately, support for this model, and we specifically need 3 manual support. What this does is it generates 3 supports, but only where we specify it. This might be a little bit different depending on the slicer you are using, but it should be in all of the slicers, or at least most. So click on the model and find support painting or paint support. The tool type should be some sort of fill, smart fill, something like that. Turn the model around and find these spots. On the pedals, we got 4. These are the bottom surfaces. Should look like this. And then if you are using side buttons, you also need these 2 surfaces. That should be it. Slice it. Now you can see we have supports that are only going to the surfaces we specified. These supports are really thin, and the surfaces they support are also quite small. So what you can do if you're having trouble is reduce the top Z distance to 0. This will basically fuse the support to the top surface, but it doesn't really matter because there is another sacrificial part on top of the supports we are breaking off anyway. Now let's just go through some small things. If a brim is being generated on this, turn it off. It will mess your print if you keep it enabled. And sometimes what happened to me is that the model had some holes in it, especially around these areas on the pedals. We just looked bad and it was way weaker. So if you have holes in these parts, you need to reduce the retraction on your printer. So you can see it's in the printer settings, extruder on AutoCAD slicer, and I reduced it to 0.3 from 0.6. I think that should be it. Hit print. Okay, so now we got it out the build plate. First we need to remove the support. Now, especially for the version with side buttons, it might be a bit difficult to remove these on the side. I'd recommend using some sort of pliers. Now the second one. That looks fine. Another thing, the USB-C port here, there might be bridge kinda hanging down, which might prevent the USB-C from sliding in nicely. So what I like to do is go with X-Acto knife there and just cut it out a little bit. This is specific for the side button version, but you can see again the bridge is here kinda hanging down, which is not what we want because we need these buttons to go in there and slide easily. So again, we need to take the X-Acto knife and clean it. Nice thing is you have the side button, so you can test it out if you did it enough. Now you can see it goes in there. Okay, now let's go to the pedals. Here you can remove the supports that are kinda hanging off like this. I broke off the support with the block in there. There is another block right over here. These are the scroll wheel blocks. When you are holding it, when you're breaking off the supports, don't hold the body like this, right? But hold it here by the actual pedal, so you're not stressing these thin parts. So now the point is to break off the button blocks, and don't use something like this for it, but rather something like this. Hold it like this, hold the pedal, and then try to snap it off by bending it to the side like this. Then the same for this one. Break it off like this. It should leave a clean contact. If it's not clean, just take it with X-Acto knife a little bit. You hopefully won't need to fine-tune it later. The surface still might be rough, even with the settings, so you can clean it up again with an X-Acto knife a little bit. What you need now is a small Phillips screwdriver. It's this one, PH0, and unscrew the 4 screws on the bottom. Now take it up here, push on it, should come out. Yeah, just like this. Take this ribbon cable and the black part on the connector, pull it out, take out the cable. Since we are doing the side buttons, you need to take out the side buttons with these 2 screws. Now it should just come out. Save those 2 screws, we need them for the mod. These 4 screws we don't need for the mod. Unplug the battery. There is a small clip on the back side which you need to push, and then it should slide out. Unscrew these 3 screws. We are going to need those, so put them to the side. The PCB now should come out. You can remove the scroll wheel like this. This is the power button plastic piece thingy. We don't need that. Now comes the most annoying part of this mod, and that is removing this battery from this bottom piece. I have some alcohol here, which should help with it. Just gonna spray down there and wait for a little bit. Let's try removing it. I got this carbon fiber thingy. You don't need it. Try something like a credit card to slide it under it. Don't use a flathead screwdriver because you are going to dent the battery and damage it and potentially cause even a fire. I'm pressing down so that I'm scraping the plastic piece and not the battery. We got this black piece stuck to it. I do try to remove it so it looks better with my fingernails like this. Now we got that. We can put the PCB inside the shell. It's a bit difficult to put it in there, but it's definitely doable. Like this. This PCB piece should slide in this hole. This USB-C should be fully slotted in the hole here. Then put it on the table, press the PCB down, and it should fit perfectly. Take the 3 screws which held the PCB down originally, we're going to reuse them. One thing I recommend is holding the mouse down on a flat surface while you screw the PCB in, which will force the shell to be flat. That is it. Now what you should test out is the buttons, if they feel good. If they don't feel good, several things might have happened. One of those things is that the button blocks might have broken off in a bad spot. If that happens, and especially if you are printing your own shells, just print them again, honestly. It's less than 10 grams of plastic and it's just going to make the mouse better. If they broke off correctly, there might be a little bit of plastic protruding out of it. In that case, you can fine-tune the buttons by using X-Acto knives and carving out little bits of the plungers. But hopefully you're not going to need to do that. Now let's put in the battery. This is the new system that I made for this update. You don't need to use it. If you're using a different size battery, or you have the MET-R Plus with a bigger battery, or whatever, you don't want to use it, you don't have to use it. You can just cut off this spring with an X-Acto knife, like this. And then if you get it out, you can just glue it like here. So what you need to do is put it like this. Slide in the cable inside of here, like this. Put the battery inside, then slide the spring over it, like this. You need to take the cable and push it in over here, like this. Then on the other side, you pull it out. The length is exactly correct, so it's a bit difficult. But now you need to line it up so that the latch is on the back side and just slide it in there, like this. Now the side buttons. Side buttons work a little bit differently in this mod. Originally they are like this. In this mod they are flipped, like this. This means that you need to flip the back and forward buttons in the software. Now we need to insert these 3D printed buttons inside, like this, and now put the side buttons on top of it. I'm not reusing the original screw holes because they are quite far, so I'm just using 2 of these separate holes. Now take the 2 screws which originally mounted the side buttons and screw it in. Now what we need to do is connect them with this ribbon cable. And what you also need to do is flip the orientation, because we obviously flip the orientation of the PCB. Put it in, and then we need to press in the black plunger. Now that we have it assembled, we can put in the scroll wheel. Okay, now let's get to the grip tape. You don't have to use the grip tape, but I do like it quite a lot for this fingertip mod. I will be using this Talon Games universal grip tape for that. I also use some piece of scrap plastic or wood. Take some of the guides, find a good spot for it, press it down, and then go around with the X-Acto knife. Should now pop out. Do that with the other ones. This smallest one you need to do 2 times because it's one for the index finger and one for the middle finger. Okay, now that we got it, we can start putting the grip tape on. I like to use tweezers to peel off the back paper tape and just line it up. All that's left are the skates. For this I'm going to be using the Ultra Glide Ultra Ice Run skates dots. Again, I'm going to be using tweezers for this. The placements are pretty important. You need to put one here, here, here and here. But you can see there's a lot more spots where you can put them if you need to. I usually just use the 4 main ones. Now that we got this, don't forget to remove the foil from the dots. And yeah, that is it. So this one is 20.4 grams. That is with PLA and side buttons. My main one is this one. This is ASA with no side buttons. And this one is 17.2 grams. I hope you enjoyed this video. I hope it was helpful and you enjoy my mod. Thank you for watching. Bye.